This video is for discrete and continuous functions. So a discrete function has a graph that consists of distinct points. So it's just points that are graphed. A continuous function has a graph that is connected. So the points are connected to form a line or a curve. But the difference is discrete is just the points, continuous, they are connected. So on the inside here, graphing discrete functions, it says graph the function y equals 2x minus 1. And then here it gives you the domain and then identify the range. So what you would do is you would take just these x values, plug them into your equation and find the y, and then you would graph each of these distinct points and you would not connect them. So the same thing with graph the function y equals negative x plus 4 with the domain. So here it gives you the domain. So you would just plug these x values into your equation to find your y values and then graph just the points. So now your range are your y values. And when it's a discrete function, you do just individual points. It's not going to be a set of points. It's not going to be through a certain amount of points. They're going to be individual. So however many numbers you have in your domain, you better have the same in your range. So continuous functions says graph the function y equals 2x minus 1 with the domain x is greater than or equal to 0. So in this one, what you would do is you would start at 0 and pick a couple points, plug these x's into your equation, get your y's, graph them, and then you would connect them from 0 and again greater than. So make sure your x's are greater than 0 and it's a line. So your range, again, you look at whatever your lowest y value is. And so here it's a -1. And so it's going to be anything greater than -1. So with this one, it says we're going to graph this function y equals negative x plus 4 with a domain x is greater than or equal to 1. And then we're going to identify the range. So we start at 1 and go up because x is greater than. Find our y values and plot these points and then connect from 1, x is 1, to greater than 1. So our range here, we're going to start, here's our first y value, and you can see our y's go down. And so our first y value is a 3, but there's nothing above 3. So y is going to be less than or equal to 3. So in the bottom part of this, identifying discrete situations. So explain why the situation is discrete. So here's your number of movie tickets. And so one movie ticket cost $8.50, two is going to be $17. So the reason this is discrete is you cannot purchase a part of a movie ticket. You can't purchase 1.5 movie tickets. So there's some things that fractions aren't going to work, decimals aren't going to work. So the same thing down here, points during a game of laser tag. You either hit the target or you don't. It's impossible to hit half of a target. So you're not going to hit, again, 1.5 targets. So now these are continuous situations. So this is the temperature of a fish tank during an experiment. So the time in hours is listed here, 0, 1, 2, 3, 4. At 0 hours, it's 83 degrees. At 1 hour, it's 80 degrees. You can see the temperature's going down. So time is continuous. Although the table only displays the temperature after hour increments, there was a corresponding temperature, say at half an hour or an hour and a half. And you can even do 2 1/4 hours. There would have been a specific temperature for that time. And so there was a corresponding temperature at any given time between the hours shown. So the next one is the height of a rocket after launch. And again, time is continuous. So again, although the table only displays the height after 1 second increments, there is a corresponding height at any given time. So you can have half of a second. You can have 1.5 seconds. And there would have been a specific height that that rocket was at. So that's it for this video.